Hello, I'm John Joshua Bilonia and I'm back again with another Python experiment video. In this video, we'll be tackling experiment 7 regarding functions. For the first for the first part, we'll be writing our own function. So, the objective is having parameterized functions and utilizing the return statement while also testing the functions. So, the scenario is basically having a code that determines if a year entered is a leap year or not. So we have this test code right here, and I've encoded it here. So this is the test code, and from there on, we will construct our code. So the first line in here is defining the function named isYearLeap with a parameter of year. So we'll be first defining that function. And is in essence, what we'll be doing here is encoding a function or many lines of codes that determine if a number entered is a leap year or not, just like on the previous experiment. But in this case, we don't have to take into consideration the 1582 creation of the Gregorian calendar because it is not mentioned. So 4 AD is considered as a leap year, even though it is before 1582. So with this in mind, I remember the rules for making the leap year. So basically, we can simplify the rules of having a leap year by saying that if a year is divisible by 400, it is a leap year. If it is not divisible by 400, but it is divisible by 100, it is not. However, any number besides that is divisible by 4 is sure to be a leap year. So those are just 3 rules. Very simple. Not like the other experiment. It's complicated. So with that in mind, we'll have first an if statement that if a year is divisible by 400 exactly, then it should be a leap year. So in this case, I'm gonna encode true. So we're gonna represent true as a leap year because here in the test code, we have here that in this line 14, if the result or basically our code, if the result of our code is equal to the test results, so the test results are Boolean values. So our result in this function should be Boolean values also. So as we can see, false indicates non-leap year, true indicates leap year because 2000 is a leap year, and so on. So if the year is divisible exactly by 400, then it is a leap year. Else, if it is divisible by 100 exactly, but it is not divisible exactly by 400, then it should be false. However, anything besides that is divisible by 4 is a leap year. So we'll return this as true. And then, yeah, whatever else is remaining, we should return as false. So the return statement just indicates what our custom function or our defined function would return to its caller, to the part of the code where it is called. So it would return these Boolean values. Okay, so now that our code is done, we should be able to run it. So the point of success is having 4 OKs here because we have 4. Let's test it. So as we can see, there are 4 OKs here. So our code is doing good. And we'll have to copy our code here in the Word document. So here is our code. And this is our observation. Compared to the previous experiment, there is a better way to determine leap years. Like what I've said, the 3 simple rules: divisible exactly by 400, leap year. If it is not, but it is divisible by 100, it is not. Anything else besides that is divisible exactly by 4 is a leap year. So there's just 3 rules. Also, defined functions must always contain the return statement, or else it would return none or a null value. So if we omit the return statement, it would return nothing. So moving on to part 2 on how many days, writing and using your own function. So basically, the objectives are the same, but the scenario is a bit changed. So our task is to write a function that takes two arguments or two parameters, namely year and month, and the number of days, and returns the number of days for the given month or year. So exactly, for the February of 2020, it should return 29 because 2020 is a leap year. So it should return the number of days for the given month for that given year. So yeah. So we have here our initial function. We just need to we can add our previous function. So we can just add our code here in the bottom part of our previous code. So basically we'll just replace this test code. So the test code is replaced by this test code. So as we can see, we have two lists now. I mean three, but two lists for years and months to access, so that it could test our code. So basically, our code is here in the first line. Def is year, leap year. Your code from the preview, so we already have our previous code. We don't need to type that anymore. Then the second one, in the third line, def days in month. Then we have the two parameters, year and month, and this is where we put our new code. So we define first days in month, then we have two parameters, namely year and month. Okay, so we also have a condition here stating that we should convince the function to return none if its arguments don't make sense. So the only case that it wouldn't make sense is if the months would be greater than 12, of course, because we only have 12 months. So if the months is not are greater than 12, it should be returning none. So that is the first order that we should do. So the first line here under this function should be if the month parameter is greater than 12, it should return none because that is the condition. And then we proceed to the actual code. So here in the actual code, there is actually a trick that says that we should create a list filled with the month's lengths. So I'll do just that. So I'll have here a list called months with an S because our parameter is month without S. So I'll create a list named months with an S, and be it a list of how many days are there in each month. So the first element would be January. January would be 31. February would be, this is assuming that it is a common year, not a leap year. So for a common year, the second month would have 28 days. Third month, 31. Then alternating, we have again 30, then 31 again, then 30, then 31 again. But we have January, February, March, April, May, June, July. July and August would have double 31. So January, February, March, April, May, June, July. August would double 31. August, September is 30. October is 31. November is 30. And finally, December is 31. Counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there we have 12 months, and we have the lengths of the months by each month. So now here's the part that where the leap year and the common year would part. So basically, if we can call upon our predefined function here, the isYear leap. So if the year is leap, of course by inputting year, but let's say for the common year, because our list is for the common year, right? So for the common year, so the common year should be false. So if it is common year, basically, then we should return the value by accessing the month. So in case of January, we should access the first element of the list of months. So in order to access the first element of the list months, we should type months, the name of the list, then uh, the element number, which is month, which is the parameter month. So if we have the month January, that is 1, so it should access the first element in months. But remember that lists start with 0, so the first element should be 0. So with that in mind, we just have this -1, so that January would be 0, because 1 minus 1 is 0, and 0 is the first element of the list. And then we're good. So if it is a leap year, it should be we should replace the second element with 29, because it is a leap year in February, right? Here. So in order for us to replace that, we would access the second element, which is 1, and replace it with the value of 29 days, so that the list months would be modified. And then we just return like the other one, return month -1. Okay, now that we have everything in motion, clear here, execute. And as we see, we've got 4 okay, so our code is okay, up and running. So yeah, let's first copy the code, my new code, I mean. So the new code would be here, because I've already given the previous code, which is just the same. So I observed that a defined function can also be called inside another defined function, provided it is defined first. As we can see here, that inside this second defined function, we have inside of it the predefined function here. So we can use defined functions inside the defined function, given that it is defined first. Okay. So also, when accessing a list, it is an imperative to remember that the elements are numbered from 0 onwards, not from 1. Part 3, day of the year. Writing our own functions. So basically, same scenario, but this time we will be converting the dates into what day of the year is it. Let's say January 2. January 2 is the second day of the year, because it is 2 days inside the year. And for instance, February 1 is the 32nd day of the year, because January has 31 days, and then we have February 1, the first day of February. So 31 plus 1 is 32. So February 1 is the 32nd day of the year. So basically, we're gonna write a code with our previous code. We just need to add some more codes in that. And here's the test code. I created a custom test code of my own. So we just replace the test code here. That is very much similar. As you can see, we have years, we have months, and now we have days, 15, 22. So basically, we have February 15 of 1900, February 22 of 2000, January 31 of 2016, and November 2 of 1987. And then we have the correct answers here, as I've calculated. Okay, and then we have 3 here. We have year, month, and da, which is year, months, and dates. And basically, yeah, it's basically the same code, but we just added days. From years, we added months, and then we added now days. So as we can already see, what should be the name of our new function though? Our new function should be defined as, here in the picture, as in line 11, day of year, with the parameters year, month, and day. So def, what is that again? Days, day of year, day of year, with the parameters of year, month, and day. Okay. So basically, uh, since we just added day, we should copy the previous code from the month. So we just literally copy this and paste it here. And so here we can see that we have the number of days in the month. But let's think of November. If in the event that we encounter November, we should be adding the days of the year from January plus February plus March plus April and so on and so forth until October, then adding what is the day in the November, so that we may be able to access what is the day of the year. So with that in mind, um, let's say if we gone to November, that is only here, this is the month of November, but let's say November 1, so we should not be counting November per se, but we should count the sum from November downwards, not including November. And then if we got the sum of these numbers, we should add the day in November. So if November 1, we just add all of the highlighted portion, and then we add 1 because it is November 1. So in order for us to do that, we should modify the list such that because there is a function called sum, wherein if we insert the sum and have the function in the list in there, let's say sum of months, and then the sum would return a value of what is the sum within the list. So we don't want, in the case of November, we don't want these last two parts to be summed. So in order for us to do that, we should remove the last parts of the list months. So in order for us to do that, I'll be building a while function or a for function. I guess a while, because while the function is not this length, we should delete the last, we should remove the last element so that we can add everything, not including the future months. So in order for us to do that, we'll have here under here, oh, let's delete this. No, let's delete. We have while the length of the list is months, where the length of months is not equal to the parameter month minus 1, as usual, month minus 1. That is to say, if we've got, let's say we've got February, so February is 2, so 2 minus 1 is 1. So while the length of months is not 1, that is only January, so that we could add the day of February, we should remove the last element. So in order for us to remove the last element, I've searched up the net and found this function, the pop function. So as you can see, there is a list, and if we introduce the pop function, we will have removed the last element of the function. So with that, I'll use it with the name of the list. We have pop, the pop function. So while it is not equal to the length, we should remove and remove and remove and remove and remove. Okay. After doing the while, we would have the else, of course, because when the while function stops, we should call for the else. We should return a value of the sum of the list of the months, because it is now the right number of length, and plus the parameter day, because it is the day of the month. So this is every month before that month, and then the day in that month. Okay, so the same thing goes with the bottom part for the leap year, for the leap year too. So basically we just copy this while block. Okay, so now that we have finished this, let's play the code and let's see if we could have okay. And we can see that we have 4 okays. So we'll just have to copy this code, this new code, and paste it here. So here are my observation. So this exercise is pretty much like the previous one. Basically this experiment could be expanded to hours, minutes, seconds, milliseconds, etc., with very much the same programming, because it's just, branching from leap year to non-leap year, and then to the months, and then to the days, and then to the hours, with just very much the same programming of while loops and anything. We could pretty much extend this experiment to that extent. So in our conclusion, a custom function can be used by first defining what it does with existing functions. This way, copy-pasting chunks of code is unnecessary every time that function is needed to be executed. Like this chunk of code. Imagine copy-pasting this lengthy code every time that we need the function day of the year. It's too bothersome, and it's an eyesore. And it is important in programming that we reduce the eyesores as much as possible, so that it should be readable and understandable by other programmers as well. So going on, these functions can also have parameters, which are basically local variables that could only be accessed inside the function only. This is opposed to global variables that can be accessed anywhere within the code. Having lists significantly reduces the code's length, like earlier. It is important to bear in mind that elements in a list are assigned to values starting from 0 and not from 1. In essence, the first element is 0, the second element is 1, etc., etc. Lastly, defined functions can also be called within other defined functions as long as it is defined first. Thank you, and that is all.